recycle project. And this is just an information item only. This is so Roger can give us some information, we can ask some questions. This is not an opinion time, this is not a decision time. So I'd like to keep it to just questions and clarifications on things that he's bringing forward to us tonight.
Okay, very good. Thank you very much for the opportunity to come here and update you on the project. The presentation that I put together, I'll try and keep it fairly brief, but obviously feel free to ask questions along the way. It's meant to sort of dovetail with a memo that we had prepared. I don't know if that was
It's in the back.
in the packet. Okay, so a lot of the information here is meant to go along with that. And again, just a recap of what this project is about. It's to convert the process from discharging the process wash water that's generated through the primary treatment process. Instead of discharging that to the environment, to the reservoir, the process will be now to modify that and recover and recycle that and return that water to the head of the plant. And so couple of the drivers, or in terms of goals that we look at for a process like that, is be able to optimize that treatment process. And when we're reintroducing that water, that's the Department of Public Health, which regulates that. They have established certain goals that they are looking for that. One of those being the clarity of the water, the 2 MTU, so that establishes a level of treatment and clarity for returning the water. And then the 10% return recycle rate, so that's to say that you're not returning all of this water all at once and overwhelming the treatment process. And so they put limits on that, and that's also from a public health standpoint. The 10% number is usually enforced much more closely by the Department of Public Health, and so we'll talk about that in terms of some of how that might impact the plant here. And again, this project here is to get away from maintaining the NPDES permit that the district currently has for discharging that. And along the lines here, the last point about improving solids dewatering, I mean, a lot of what we're talking about here is optimizing not only the treatment of the return water, but also the solids that are also generated as part of the treatment process, and coming up with a more efficient way to dewater that and ultimately haul that off site. And so just a little bit of background and a reminder here of kind of where we started with the whole project. Our scope was, we started off the project by doing an initial screening of several treatment approaches and treatment technologies. And those three were, the first one, the Deskin's Quick Dry. That was a sort of a proprietary system, primarily a sand filter bed. It's kind of it's one of a kind. You can, I mean, we'll just leave it at that. It's basically a proprietary system. We looked at that both with and without thickening, and the purpose of the thickening, and the picture below is a picture of a sort of a typical, what they call an inclined plate settler, where you would first take your wash water, which is mostly water. It's got solids in it from the treatment process. When you back flush the main treatment equipment, it's got solids, and the purpose of the thickening then is to separate a lot of the water from the solids. So you don't separate it all, but you take it from a fraction of a percent solids to maybe 1% or so, which makes a big difference in terms of cutting down the volume. And then from there, that water would be, the main water would be clear enough and treated enough to be able to return that to the head of the plant. The solids would be sent to drying ponds and allowed to further dry there, so it helps speed the process along. And then the third was looking at what we call the line basins, essentially taking the pond areas that you have right now and excavating them out, making them deeper, putting in a liner to comply with, also with state requirements there for handling that.
That's kind of like the pictures were stacked off.
And that would be the top picture right there.
Or was that placer or something?
The upper one is Grass Valley.
Grass Valley, okay.
For,
you've seen that earlier.
Right, for the Nevada Irrigation District. And so, yeah, so that's the typical liner with an under drain system, and then on top of that, you would put a sand media, and then the solids would be deposited on top of that. So those were the three options. When we did the initial screening, we looked at the thickening. We looked at it primarily from an energy standpoint, to look at that, what the impact would be and the difference of pumping. And what we found at the time was that there was essentially a long payback period for that equipment. And so we sort of ruled that out at the time and proceeded on with the lined ponds. And that was brought to the board here back in September. And so we were moving forward with that project. And so this is just a basic schematic of what that looks like. And essentially, I mean, what's primarily new are these ponds right here. And so we would be looking at reconstructing, at the time we were looking at reconstructing both sets of ponds that the district currently has, which are located across the road. And I've got an aerial photograph. You're probably familiar with that, but I'll get to that here in a second. But this was really the bulk of the improvement, and so the costs associated with that largely were for the excavation work, for concrete work, for lining, and as well as the pipeline to bring the flow back down to return the water to the head of the plant. So that constituted the majority of the cost for the project. And in our draft preliminary design report, that was in the order of about $3.5 million or so. So what we commenced then by conducting some field work, both getting some more topographic survey data to be able to come up with our accurate layout for the facilities up there, as well as a geotechnical investigation and just characterizing the site. One of the things we did find was on the pond that was more recently constructed, it looked like there was a fair amount of seepage occurring there, and so that helped us to identify some additional site work improvements that would be necessary to probably remove that soil and recompact it, so that boosted the cost there somewhat, as well as just the sort of the characterization of the amount of rock and the fact that the other set of ponds that is basically carved right into the rock, so it would be a good amount of rock excavation here to be able to deepen those ponds. So we conducted that field work in the fall, and from there we integrated that information and kind of over the holidays and such, but we submitted a draft preliminary design report at the beginning, right at the beginning of February of this year. And over the course of doing that, and then as district staff reviewed that, I guess we sort of came to some collective conclusions here on the project that made us rethink the scope of the project. And the first involving the controls and the integration of the backwash and the recovery process with the overall plant controls. And with the plant, with a lot of the facilities, and it's not entirely unique, but it is the amount of manual operation of the facility, I think, there are some unique aspects to that. And so that has an impact on how that recycled water is returned to the plant. And so that sort of added a level of complexity here that we needed to address. And then likewise, the second point on flow equalization. And there's some recent data that district staff had pulled together and identified, and we had originally identified that there was going to be a need for flow equalization, but the quantity of it was, we'd underestimated here initially, and so I think now we're looking at greater flow equalization volumes. And so,
can you explain that a little bit?
I sure can.
What flow equalization is, why it's needed, and what it's for?
Absolutely, and that's the purpose of the next slide. So again, back to this 10% recycle rate, and again, the goal here is to be able to control and put an upper limit on how much water, how much of the processed water is returned to the head of the plant. And again, that's from a public health standpoint. And so we're trying to keep that below 10% of the total plant flow. And so during many times of the year, that's not an issue for a couple of reasons. One, especially in the summertime when plant flows are going to be higher because customer demand is higher, 10% of that flow is obviously a bigger number, and so you can return more of that flow. And at the same time, a lot of times you have the benefit of having better treatment, and so your amount of wash water may not, isn't going to go up at the same rate. So you're able to comfortably stay below the 10%. At other times of the year, it can become a problem because you can have the exact sort of flip. You can have lower customer demands, lower plant production, and then you can run into say a particular water quality event in the watershed or so that requires more frequent backwashing. And so the purpose of the equalization then is to basically serve as a holding reservoir to when you do run into those situations that you can store the water temporarily and then kind of gradually control the feed rate back to the plant. And so this is a graph here. This was, again, some of the more recent data. And so what the red line shows you is, and again, this was data that was pulled together by Neil, I believe it was. And so the red line basically shows that volume that needs to be held, and it's a collective number. And so you can see that, that these blue lines right here show the actual wash water that's generated. So when these lines are close together like this, and here we're at the end of October, so I think we're already coming off into a lower production period, that every time you generate that wash water, you have to store a little bit more of it, and it just sort of keeps building and building until you get up to this point here. And this is a continuation of this is a sort of part 2 of a graph here. So this event actually started, I think, a week prior to that. So it started at 0, eventually got up to 1.2 million gallons, and then once these wash water, the frequency of the wash water gets expanded out a little bit, then that recovers and comes back down. But this number here, I think originally when we were first looking at that, we were thinking in the order of under 500,000 gallons of storage. Which we were looking at holding in the ponds themselves, but where we're looking at a single event here where it gets up to over 1 million gallons, and it the next event it could be larger, and we just don't know. I mean, there's a fairly limited amount of data based on the current treatment practices here, so again, it could be more than that. We just don't know. So any questions about that? Does that make sense?
How many gallons is in one of the holding?
Each holding pond held, and so each holding pond was divided into 2, and it was in the order of, I think, 300,000 to 400,000 gallons of what each one was capable of holding here. The whole pond. It was essentially half of
one.
Right.
Can we demo the whole treatment plant and put a tank in the yard that will hold this?
Typically, the whole plant's part of this process.
Part of the structure?
Part of
Part
this
of this whole
process.
project, and he'll show you.
There is a demo of that plant?
Yes.
Congratulations.
That big?
That's a
We're
big
gonna
mountain
see
and
that.
then
I
We're gonna demo it
joke about
before we
taking
take
it
off.
into
I want to
a
make it as a helicopter.
So what that led to then was, again, sort of reevaluating the overall approach and the overall project and the process for treating and recovering the wash water. And so what this is sort of a listing then of the new facilities here, the new pieces to the puzzle then that would go into that. And so whereas before we were primarily just talking about improvements to both the north and the south ponds, now we're talking about focusing just on the south ponds and not touching the north ponds here, because we're going to go talk about why. But these are all of the components then that would go into the new process. And so, and I'll just walk through these here real briefly and feel free to stop and ask as we're going along. But one of the first items there was looking at, basically these two here are related. So you've got the flow equalization at 1.2 and planning for, a little bit of safety factor on top of that. And so we've got, right now we show it in two locations. One would be in a second wash water holding tank, which it would be next to the existing one. And what that provides is some additional redundancy. I think that tank is original to when the new plant was constructed. And there's no way to go around that, and there's no backup to that. So this one option would be to look at adding a second tank. That tank by itself is only in the order of 200,000 gallons or so, so that wouldn't be enough. And so that's where we'd be looking at a much larger flow equalization basin to pick up the slack and basically serve as that function. Next, we'd be looking at basically a new pumping scheme. So whereas before we were relying on the existing pumps to just pump the water up to the ponds and let it settle out there and then return the water, now in combination with these package, and so now we're revisiting the package plates as our option, but it's serving a different purpose now. It's not just for energy conservation, it's actually providing better process control, and we're thickening the sludge at the same time, so we're kind of getting double duty out of that. But what this requires then is a little bit more precise pumping control, and as well as, we've got different hydraulics now. Now instead of pumping all the way up the hill, we're only talking about pumping to a lower elevation. So we're looking at new pumps with variable frequency drives, and those are attachments to the motors that allow the pump to speed up and slow down and be able to control that rate of flow much more accurately through the treatment process. So it provides the flow equalization, but more importantly for the treatment equipment, it provides pretty steady state control flow through there and better treatment process. Yeah, Bill?
This sounds like a lot of money in my mind immediately. It says, how are we going to recoup millions of dollars out of this thing? Is there a way for us to get some payback out of it other than recycling the water itself?
Well, I don't know. I've got the cost number here coming up.
Unfortunately, CPA, I don't think is interested in us recouping money. They're just telling us what we have to
I mean,
do.
the best upside of this project is that we're gonna save 400 to 500 acre feet a year.
And
Right
that's
now it
what-
goes down the street.
Okay, how much is that worth when we're selling it?
Well, I didn't count that yet. I'll have that number when you make a decision. But just to equate it, we were looking at probably $1.5 million for the bladder dam, which was going to provide 758 feet of storage, but not every year, so it's kind of equivalent to that.
Except at the expense side.
Well, this isn't an expense. I don't think it's not an A and B question. It's not a yes or no
Not much
question.
generator.
We have one box to check, and yes is it, and it's just how we approach this project. It's where we can conserve money, where we can optimize it for longevity. I think it's really should be our goal versus dollars.
Maybe last.
I remember
One of the things that I always talk, Bill and I both say, don't build a Clendenin version, which is what the circle is of our solution.
I remember one of the first days that I started attending, when I knew I was going to run the board. And you mentioned that we perhaps would save up as much as 600 to 650 acre feet every cycle. So it would be 4 or 5. So that's pretty significant amount of water we save.
Yeah, the value is the value. I mean, I'll run some numbers so you know what it is, but
Any savings on PGD bill by running more efficient pumps?
no.
Public ask questions.
Yeah, I will. You need to ask him. Sorry.
If you don't mind, is a dewatering basin what used to be an evaporation pond?
Essentially, I mean, what they're using right now, if you want to call that
I understand it's changed, they can charge more for it.
Right, yeah. But, yeah, but, you know, at the same time, it was by adding the under drain system in there to be able to speed the dewatering process afterwards, so, but, and to increase the capacity of them, because if you've seen them empty or so, you know that, you know, the ones that are on the south end of that area, one of them's actually relatively shallow, and you've got, you know, kind of a big berm area that we were looking at taking out, just expanding the capacity of it, so.
As I understand it, remember from the previous meetings that we had on this, and I'm observing, this is mandated by the state. And by a certain date, whether that's 2015, they can start charging us up to $1 a day per meter. Which is not very much, but when you have 10,500 meters, that's quite a stack of money. Is that true?
They charge by the gallon.
Oh, yeah, okay.
Gallon of
Well,
discharge.
somebody said $1, and we'll figure out $1 a meter. I don't know. And then the other thing was saying, you know, right now, I got this from Jim when I had my tour, we pump that water up, and most of it, or all of it, and then run over the top, is actually percolating down into the grid, enjoying it.
Right.
And that water is much purer than the lake water in the gate.
A lot of times.
But that doesn't make any difference fish and game.
Yeah.
So anyway, it's kind of between a rock and a hard spot.
Like I said, this isn't an A and B question.
No.
We don't have a choice in this. We don't, the only thing we can do is choose the best solution and make it a longevity solution. Exactly. That way we're spending the ratepayers' money in the wisest way.
The big old round tank that's out there at the treatment plant, that would be changed or be used or painted or something.
Remove.
Well, I think
Removed,
a picture of the old tank right behind Rogers' tent.
Right, yeah, right there.
Right, yeah, so.
That's
Right
right
there.
there.
Right there.
Yeah.
Right there.
Yeah, we want to keep,
How long has this since that tank has been used?
95.
I'd go right back 15, 20 years.
Still paying for it.
Still paying for
Still
it.
bad over here.
That was well thought plan.
I think you wrote it off.
We may roll it off, but we're still paying for it.
Still bad for it.
Go ahead, Roger.
So schematically, you know, this is what it looks like. You know, this is the existing raw water tank, which is right there, just kind of for illustration purposes. Here, right here is, you know, where the wash water comes from out of the treatment plant, which is this tank right there. And so, again, with all the features that we listed before, if we look at adding a second tank that, you know, provides redundancy in this holding area, and then that water, we would be pumping it, we'd be trying to use the existing pumps. Again, it's different head, but, you know, because we're not pumping all the way up here to the top where the ponds are, but we'd be looking at trying to reuse the pumps there to basically be able to pump the water into this equalization tank. And that tank is pretty large in order to, and right now we've sized it for, you know, for the purposes of estimating the cost, we'd size that for 1.75 million gallons, so that basically the combined total for this second tank right there, as well as the new equalization tank, was in the order of about 2 million gallons. And we can look at that here more closely, but just kind of for a placeholder number, we thought, well, that puts, I think, a pretty good safety factor in there, just to, you know, make sure that we can
So the tank
handle the
right
future.
at 800,000, that tank right there, how much is that? No,
This-
the tank, the actual picture, the real picture you got the tank.
This right there is, I think, about 200,000 gallons.
200,000.
Yeah,
Is that the old one?
that's the existing one, yes, right. And so then from there, the water would be pumped, and these are the new pumps with, you know, again, more efficient motors and variable frequency drives that allow you to pump the water into these inclined plate settler units. And right now, I think our current cost estimate, we've kind of gone back and forth looking at 1 versus 2, and I think right now we've settled on 1 initially with planning for space for a future one, you know, again, for added redundancy down the road.
There's inclined plates, as you call them.
Yes,
Will those be on the uphill side, up right where the current ponds are at, or will they be located?
they would be located, and I think it's my next slide, I think that'll show where that is. And you know, there are different ways we can do this. The way we had originally laid this out,
How would we clean those?
clean these. They're actually, you know, typically what you have is you have sort of a working platform around the upper end, and You can kind of get in there, from the top and hose them down. You put like a big pressure water line there that you can go in there and hose them down.
Well, I understand the current project, now I've got to look at some of the material that's non-toxic. They basically let perhaps get in there with a piece of equipment and pump it up.
Yes.
The stockpile, there was a big stockpile, there was all over there.
Yeah,
Is it, huh?
that wouldn't happen in these plate settlers here. These plate settlers here, what they're designed to do is get those solids to thicken up and settle to the bottom. And then you basically pump it out as a slurry
Okay.
and send it up to the ponds where it does then dry.
Okay. But when you want to get rid of the slurry, so how do you get rid of it?
Pumped up.
It's pumped.
Yeah, so the slurry
Now,
from
that's
that,
evaporated and then
Maybe we need to look at that line.
so the slurry then gets pumped up to the ponds. And so, this part of the process is similar in a lot of respects to, what you're doing right now. The main water then, and this is, also one of the keys that, as we're laying the facilities out, is trying to set these plate settlers up high enough so that we can actually flow by gravity and return the water back to this point right here, so at a lower elevation. So that elevation there is somewhat tied to the maximum water surface elevation in this tank as well as here. So anyway, you can see schematically there are a lot more arrows, there are a lot more places where the water and the solids are going. And so it just, it's a different project. But it's also, it's a robust process. And so you've got a lot of redundancy here. We've got, the ability, part of the thing we've been looking at here is the ability to bypass this tank if in the future, we're looking at a steel tank, and steel tanks need to be taken out of service periodically, recoated, painted. So to be able to actually pump the water directly up here and use these ponds temporarily while anything like that happens, or whether we need to bypass the plates themselves and, basically be able to rely on Mother Nature for that.
Well, I remember one of the, in fact, I went on the 40th, so it must have been October or September. We were looking at 2.6 million was the figure that was out. Yeah, you say robust. Well, when somebody like you tells me it's robust, I immediately see dollars in it real quick. So maybe we're too early to talk about that.
I think we're 2 slides away.
Okay,
So
good.
And again, this is just an aerial photograph, and so where we're looking at is, and my next slide will actually show that on there, but essentially looking at this equalization tank. First of all, the second wash water tank would be constructed here. Again, one scenario would be it would be constructed here next to this one. And for those of you probably all are familiar with the topography out there. I mean, you're sort of perched on a hillside there, and so this is not inexpensive real estate here to construct. It's going to, you've got a fairly significant, structural retaining wall here, foundation and all that, just to make it ready to accept the tank. The larger equalization tank would essentially go in this area there. And what we've been looking at currently has been basically to put the plate settlers up here. Again, that gives us that elevation to be able to back or feed the treated water back, and the tie-in point is down here so that we are downstream of the tank and the pump. So, we're looking at a new pipeline coming down to this area. The solids then, or the slurry that's coming off of incline plates would essentially go underneath the road here and then up to the ponds. And so let me go to the next slide. So again, this kind of zooms in a little bit, so it's a little different scale here, but again, the second wash water tank, flow equalization, incline plates, one, and then space for future, and then, the various pipelines going up the hill, as well as to the final recycle conveyance point there. So, any questions about that here so far?
the incline plates, the reason you're thinking of a secondary set may be necessary would that be because they're going to tighten up the regs, and we might have to get more, or are you thinking that of growth, and we might have to treat more water?
Now, there's a redundancy factor which helps you take one off while you clean the other
The
one.
other one, exactly.
You can deal with it now. The other thing that I'm always reminding everybody of is, part of this design is based on our pristine watershed. So if we have a fire in our watershed, the component of dirt in our water could increase considerably, which will impact the capability of the plant like a process like this. So you may need additional plate settlers to deal with the additional amount of sludge generated.
So I like that you got, the redundancy package in there, just, I wondered what you were basing it for.
The question I have is with the plate thing, that's where the McNabb cypress is, so it's sitting on serpentine rock, which is essentially, what's the?
Asbestos.
Asbestos, and it's not a very good thing to build anything on, I would think, so.
Fire retardant.
No, but it's soft rock and great.
Towel.
Huh?
Towel. Call it towel. Towel. It's a towel.
Yeah, but, yeah, so
Also the state
how are you
law.
gonna build that thing for it's secure and that kind of,
I'm sure that in a way anchored in.
well, I don't know how deep that serpentine rock is. I don't know.
Yeah, well, and that would, then part of the scope then, if we, as we move into that, would be to bring our geotech back out and start exploring in those areas. So I mean, we're aware of the serpentine that's there, and we'll have to make the design, accordingly. I mean, one of the good news is, I mean, from a foundation standpoint, structural engineers, I think, generally like it. I mean, it's good, pretty solid material. I mean, we have to take its properties into account, but it's a whole lot better than constructing obviously on clay or fill or anything like that. So.
I was just thinking comparing it with lava cap.
The pump lines,
Yes.
you're transferring water a long distance there. Are those underground or above?
These are mostly buried. The one part where we're looking at it being above ground would be to run parallel to the raw water line, just because you've got sort of a difficult creek crossing to get here, but most of this is buried. Now, going through this area here, since you've got a lot of existing piping, the raw water line crosses right here. That's one of the things we would be looking at here is kind of how this whole crossing area goes. But most of this would be buried, including once we go up the hill. Just
That would be
outside.
right, that would be right in conjunction to the Magalia bypass, I guess that's what it's called, the Magalia bypass.
Pretty close to it.
Yeah,
It's on the other side of the spillway.
it'd be on the other side of it, yeah. And looking, no matter what, someday somebody, some group, when I suppose we would be part of it, will be doing something with that dam, the roadway or whatever it is, and this would, they could go over the top of this with the, whatever. You know what I'm talking about? There's a bridge there now.
Yes, okay.
And someday this will all change, no doubt about it. And, so this, they can go right over the top of it, build a bridge or whatever. You think,
Over what we constructed, you're saying.
yeah, say like if they build a 4-lane highway through there, which something's gonna happen. And, they'll be able to go across the top of this without any adjustments.
All depends on where they put their bridge.
Yeah, yeah.
I mean, we initially here are looking at supporting it from underneath the existing bridge and the abutment there.
They've got sections of property we own, right?
Yeah.
Even where the road is.
Okay.
So we have private rights there.
Oh,
I believe we're talking about the section that PID owns, where they relocated the road. So therefore, if they need to build a new bridge, those pipes have to move, they'll have to pay to move them.
They'd have to move, yeah, I understand
Any other questions? All right. So, this was the cost slide. So our current estimate here for the facilities is just under $8 million. And it sort of breaks down by, for the second wash water tank, as well as the structural foundation work and retaining wall for that, looking at a little over $1 million. Equalization tank is, again, we're talking a significant size tank. We contacted several tank manufacturers, and this isn't just for the tank itself. It's the the demo work, taking out the existing structure, and just, you know, all of the work associated with that tank. Right now, we're looking at, we had based that on a welded steel tank in that size. That's pretty common. We can certainly, in the evaluation, you know, look at other materials. One of the things that George and I have been talking about is, you know, whether we would look at more of a cast-in-place concrete tank, and, you know, what all that might entail. So, I mean, there are different options we can consider for that.
I have to go back and look at my notes, and I keep all that kind of stuff, I can't carry it with me. What happened to our 2.6?
We added a few more pieces to the puzzle here.
And what we were going to do, and this is from Kevin, we were, I think George has been on that too. We were going to take our 1.6 capacity fee, we leave 1 billion, you know, because I asked this question right after the last one, you know. And so we'd have to cough up, figure out now, we're at we're $8 billion. But yeah.
Well, just so you know, Kevin's been working on options for financing. So we're trying to get more info on that. There's some low interest rate financing. We are working with Roger before we come back to you, fine tune this number, get it. But as I told staff, we're going to have a meeting and decide must-haves versus want-haves. And get the want-haves out of there, if there is any. And finalize kind of where things are going, what we're going to do, and hopefully tune that number down a little. Kevin's already talked to PID, which we can have a good chance of getting financing of $2 million from them at very low interest rates. Probably was it 1.6, 1.7% interest rate, and then whatever the difference is, we'll probably have to go out and borrow for as well. So that's the only way. We just don't have enough cash in the bank.
So you'd have all that under your, 152, where we have that meeting, that will all be installed out.
As best we can at that point.
Yeah.
It's only $750.
By then, Roger's crystal ball will arrive, you know.
That's what they told me, I said, where now are we going to get the $1 million?
$750 per meter.
That's what you said.
So in addition to the construction numbers, you know, one of the things we were going to come back with is also, you know, what the additional engineering work that's entailed for doing that, and there's just more stuff to do, as well as additional, you know, field work, more geotech, you know, to be able to, you know, look at the site and make sure, you know, identify where everything's going to go, and do geotechnical exploration work in those areas. Schedule-wise, obviously we're sort of starting again here in terms of, you know, looking at preliminary design, looking at some alternatives here that, you know, we're still working out with staff. And then from there, you know, once we get a preliminary design that everybody's in agreement on, and the cost is, you know, where it needs to be and such, then we would go into the final design, and then ultimately into construction. So, you know, then these are, you know, rough duration here that we're looking at. So looking at roughly, you know, towards the end of 2015, you know, on sort of an average construction schedule, you know, average project schedule here, both from design and construction window. So
When does our permit run out?
250.
May 2015.
Well, I was gonna say, it's not the end of 2015, it's early, wasn't it?
But we've talked to the
As long
regional
as we're-
board, and if we're making progress and
Yes.
going out to bid, et cetera, we can likely get an extension to our current meeting.
If we're just sitting here doing nothing, then that'll really get a fight.
You can-
We're in the
Quite
process.
certainly is that way, if you're making an effort, you know, that.
Are you looking, I'm aware the yard's been settling, Bill was put in for that old plant we're talking about demoing. Is that right, Bill? Is it, they're settling, I know there's big cracks in that.
They're settling around it. That old plant itself, as far as I know, is not settling. I don't believe that even sits on fill. I'm pretty sure that sits on hard pan.
Is the tank going to be
So we'll have a
bigger
good foundation.
than the
the
Concrete
tank,
Is that?
So we'll have a good foundation.
Should.
The tank that we were looking at would be bigger in diameter, so we obviously can shift it one way or another here, and that's part of what the geotech would help us determine.
Can't you see the old panels foundation,
You go
come
back
and
to-
shape it out?
Can you go back to the aerial? Just so you're kind of brought up to speed on some of the things we're still working on and kicking around from staff's idea. Rather than building this expensive tank here, we're working with Roger to consider a location down here where the old wash water ponds are. And building it in concrete so that it takes a more general contractor can do that kind of work. So it's not as specialized as a steel tank design. It doesn't need a roof. And concrete will have more expandability.
So the pressure does not need a roof.
Does not need a roof.
Okay.
And then another thing we're kicking around at this point, and we'll see how far we can get with it, is then we would put the plate settlers up here, and then potentially as a replacement to fixing this pond, we're doing some preliminary look at what's called a filter press or some mechanical means of squeezing the water out of the dirt, so that we don't have to passively dry it in a pond. We would actively press the water out of the dirt, and then we would take care of that dirt on a regular basis. Put it in a dumpster, have it hauled off, and not have to wait till every summer to deal with it. Still don't know if that cost of that, how that balances with that, or if we'll, how close we'll be able to get to that number before we have to talk, but we're going to try.
Neat idea. Ken, I know you just got here, so I'm sure you're just loaded with all kinds of questions.
I talked to George about this before.
Okay, did you have any
And I-
questions for Roger?
I have the PowerPoint too, so we can go
Unfortunately,
back.
we're at the end of the.
The thing that I'm interested in is, not building a quality tank for drinking water to hold the sludgy water. Get the cheapest container, bathtub, concrete, open air to the elements reservoir that we can. I think.
A lily cup.
Excuse me?
A lily cup.
Yeah, we had penciled out, here just in the last couple of days here, looking at, if we were to go with more of a cast-in-place concrete tank instead of a circular steel tank. And it comes close. I mean, part of what you have to look at with the concrete is, what are the physical dimensions? As soon if you try and reduce the footprint, you obviously raise the height, and as soon as you raise the height, your walls get quite a bit thicker. And so, I mean, it's kind of a balancing act here, trying to find what the optimal size is. And in your case here, where you've got limited space, free space to be able to fit some of that in there, then you have to kind of take that into account. So, but what I was going to say then is that the costs were, I think, close enough where I think it's worth looking at here in a little bit more detail.
Well, let's go back. You were talking about being robust, and I have to go back to my notes and look at it. But we went from 2.6 million when we first started talking about it. And in fact, I went up there to Jim and looked at it. Now we're 8 million. What? And inflation hadn't hit that bad. What made it go up so much? We're talking $6 million.
The extra wash water tank, the extra equalization tank, and the plate settlers. Those are the big ticket items that.
Well, I noticed on the ponds that you had a 1.8 million for reshaping the ponds. I've done a lot of that kind of stuff. Land highway and all that stuff. Well, anyway, so that's 1.85. That included the concrete, the liners, and all that, or just the reshaping?
No, that was for basically the complete improvement. So that'd be the liner and the concrete work and headboard structure for the flow of water to come in and then flow out, that sort of thing. So to answer your question, I mean, I'd say it really sort of came down to two main items. One was the integration of the treatment process, of the recycle process with the plant operations, and having dug down into that here more deeply, it's clear that being able to control that flow back into the plant and not have to have Bill and staff go and constantly change the chemical dose for all of their chemical metering pumps because this water is coming in intermittently. That requires sort of a rethinking of the entire, approach. And so before it was, obviously fairly simple. We were looking at, using the existing pumps and, so the water, as soon as it was coming in, it was essentially going out, and it was being pumped up to the ponds and then sort of, returned. It was envisioned to be returned at more of an intermittent basis. But again, from an integration of that with the primary treatment process, that sort of changes that, changes the story on that. And so,
Well, one of the things that I think, myself, what I've always tried to do, is quite easy to be a penny wise and pound foolish. That's what we gotta do. Look so that doesn't happen, looking down the road. And maybe that tank that's out there, you're gonna demolish it, and shine an example of that.
Yeah, that's what I was gonna say, is we wanna look at the number, I think we're all concerned as board members about the final dollar that this is gonna cost, but we better be looking at longevity for our investment as really our key component. Because we're not looking at that, we're gonna have another, water treatment plant that made it 10 years and then we're still paying for it. This is gonna be a long-term investment, as with anything, big project that we do, and we need to make sure that it lasts. We should be able to get, 25, 30 years before any improvement is necessary.
Yeah, the big things are pumps.
Well, things are gonna wear out, there's no choice, but I mean, as far as the overall design of the system, if we do this right the first time out, we should be able to make it 25, 30 years before we have to do any redesign or addition to the system, wouldn't you think?
I think that's
Unless we get some kind of major build out of Paradise, I don't, John and Molly.
With the exception of adding the second plate settler, I mean, I don't know where
We don't
that'll
have
fall in the
to build out.
picture. But the rest of it, yeah, you should never have to do much of anything to it.
Looking at this type of money and stuff, is there any plan or something similar to this that we can go look at? To actually see the thing work?
That's one of the
That's the
problems.
tough part.
Staff's been running around and we've, one plan will have some of it that works this way, another plan will have some of it that works this way, but nobody operates the same as we do.
What
Those
if they
ponds
had
in
some
Nevada, what were their customer base? Weren't they only like 6,000 or something? Yeah, the ones where we saw the ponds. The line basins.
Yeah, no, they have a lot of customers.
They have a lot more customers than that. Well, but I meant to use that particular, setup.
But Dustin made a good point when we talked about it today. They can take their water and put it in the canal because they have ag customers. They don't have a
Okay, I was
recycle
saying, how did
rate.
they get away with just using those? Because we had talked about those ponds were relatively close to the size of our ponds.
That was part of why some of this changed, is we went up and looked at their plant. And unfortunately, plants are all different, and our plant is way different than most other people's plants. And so after looking at their plant, we're more trying to mimic their process by adding the plate settlers before it goes to the ponds, because basically their whole process is it's working on a sludge thickening before it ever gets to the pond. And so that's what we're trying to do with those plate setters, get that sludge as thick as we possibly can, so we send as minimal water as possible through the ponds. And we're just recycling the vast majority of it straight back to the plant,
Yeah.
right off the bat.
Another Nevada water district. Instead of running it up the hill to a pond, they just put it in the irrigation ditch and away.
They could if they have to. Right now, they're recycling it. They recycle just everything that they make.
They don't need that EQ storage because they have that
Yeah.
backup.
So what are some of the other public agencies doing? I mean, are they similar alternatives, similar price ranges?
It's a pretty wide range. I mean, where folks have the land and the space, for a lot of folks, going with ponds and lagoons is something that's still fairly common. One of the facilities that, you know, we had identified early on, I think, for the Placer County Water Agency, they are, you know, are still going through startup here with the Deskins system. And, you know, there's, you know, I mean, startup is, you know, is always going to be fraught with problems and all that. I think they're experiencing kind of a high level of that here at the moment. They think they'll eventually get there, but I mean, people are using all sorts of different things, and so I mean, the cost, you know, obviously, you know, can range quite a bit. Ponds are nice when you have the space and when you, you know, when you have maybe more of the automation too, to be able to, you know, when you're returning your recycled water on an intermittent basis, that you can, you know, make adjustments automatically. So, you know, where things are dialed in on the flow, then, you know, that's something. But, you know, I think you guys have established an operating practice here that works, and it works well for the treatment plant that you have. And so, you know, to go in and, you know, change all of that for this, you know, that's a whole another added level of complexity.
Yeah, one of the things we found, because we talked about, you know, automatic feed rates for our coagulants, but it's, what we found in correcting our own bill, that it's very difficult to automate that with the water, the clean water quality we have. Those work really well when you have 10, 20, 30 MTUs you deal with on a regular basis, but our water is almost too clean to be able to automate your feed rates, because it just can't sense the change fast enough to make a difference.
We talked a little bit the other day about, Bill mentioned iron and some other products where we could change away from the chlorine-based products. It gives us one byproduct that's such a problem. Not the aluminum, but the other one. Benzene or whatever it is.
That's a byproduct of chlorine.
Yeah.
It's a byproduct of using chlorine.
Chlorine, yes.
Yeah, that's one of the problems, because we need to clean that up. He talked a little bit about iron as one of the things to substitute with, but then he's afraid it might deteriorate some of the concrete pipes we have in the system, but which are working just fine. I just was curious about these other treatment products that might change the design. And I'm sure you guys have talked about it, but did you include us in the...
Well, Jim, when we started this process, Jim Passanese put out a memo, and we'll regenerate that for you before the next meeting. We figured $2.5 to $3 million in plant changes to be able to meet this, that we didn't calculate in pond repair. Because regardless, even if we maintain our permit and get rid of some of those constituents, we're still going to have to line the ponds. They're not going to let us get away with it.
So we still might be at 5 or 6 million going that route.
And then
Well,
still have
sounds
a
better.
permit to
And still have a
contend with,
permit.
and hope that they don't come after another
Well,
concession.
exactly, they can come back and say, well, we changed our minds again. And that's it. And I think you said we were pretty good at the process that we have.
We're really good at the process.
If you like,
we have.
okay, you
Well,
want to over sugarcoat it, but you know.
Bill told a good story yesterday, to just kind of bring us here. We have this NPDES permit. We had one, and we were testing
Aluminum and dichlorobromomethane.
quarters.
Yes.
And everything was fine. And then we went to monthly. And then they went from monthly to now you can only use half of what your average delivered in the past. So our worry is, what's the next thing they decide they don't like and want? And we do this all over again. Because like Phil said,
Well,
it's a national pollution discharge elimination system. It means they don't want to discharge.
So either way, we're going to have to design some kind of settlement. Well, like I said, this is an information only item tonight. We're not making any decisions. I don't know, Roger, if you finished, if you were down to the end of everything we had there.
Yeah, so the next steps here, I think what George and I had spoken about was, you know, to come back, whether it's a special session or next regular board meeting with, you we refine the cost here a little bit more, as well as look at, what, the engineering side of things is gonna take to do that, and have a little bit more concrete number for all of you, to kind of work with at that point.
Yeah, we need to concrete number.
Yeah, we also
Do you
need,
understand why a utilization tank is required? That's one part of the discussion I want to be, I can catch up later on, but.
He
I
covered
would
it.
take
you
you-
know, cover the
Yeah, well, does the board understand it?
Yeah, we've got redundancy, so if we get rid of redundancy, we have to repair a tank, we can't repair the tank.
Well, the equalization also,
Equalization.
advice to keep that 10% that is
Get it below 10%.
So we're not doing this.
We have periods of the year, on a normal basis.
Yeah, I have his PowerPoint, so I can kind of reiterate.
Yeah, we won't do it now.
On a normal basis, we run just under 10% of wash water produced. But there are periods of the year, and last fall was an excellent example, and that's what his graph was about, where we're going along and we're still cleaning and producing wash water at a fairly high rate. And then all of a sudden what happened here was it started raining.
Raining.
And the second it rains in this town, everybody shuts everything off. They're real good about that. And it's great.
Treat him well.
Yes.
Yeah.
But what happens is the plant, as far as the cleaning process, doesn't slow down as fast as the production process does. So we still have to clean clarifiers before we can take them offline. We still have to clean filters before we can take them offline. And that's a multi-day process to start slowing all that stuff down. You can't immediately just slam on those brakes and stop it. Although your production did do that. And so all of a sudden you went from where you were doing 10% or right around 10% to now it's jumping up to 14, 15, 16%.
That chart's over 5
And
days.
you can't pull that water back through the plant that same day. So now you're having to hold on to some of your water that you're producing for multiple days until you finally got the plant wash water slowed down to match the production. And you can start pulling a little bit of extra water back in.
I gotta ask a real dumb question. Why can't we just dump it back in the Gallery Reservoir and hold it there?
Because we won't have a permit to do that.
That's the permit.
That's the whole thing. Our permit won't allow us, the new permit wouldn't allow us to do that.
If you have a point source, which is basically any confined pipe or any way to confine flow of water, you need an NPDES permit to discharge that into waters of the United States. So,
And waters of the United States include McGilly Reservoir.
How about if we take the water out of the pond
Still.
and bottle it, and sell it to the public? Probably better than bottled water.
What size is the
One
reservoir?
hell of a warehouse.
Is that the one that's up on the Skyway?
Buried in the ground.
Right, buried in the ground, 3 million or
3
something?
million, yeah.
Okay, and how much did it cost us to build that tank? You know?
B-Res?
Excuse me?
Build B Reservoir? I don't remember.
Do not remember.
We just spent, we relined it and recovered it for $800,000. I don't remember, it was a
Where
very
did you do
last
it?
minute. Actually, the plant didn't, I remember this right, the new plant's elevation didn't drive the water into town well enough. So B-Res was a quick build project, so it was done very quickly to get things working correctly.
It was done to generate pressure, is that what it is?
It was done because there wasn't enough pressure head from the plant into town
Right.
for the domain. So it was built to store water so that if
Which
people are taking
generates
it
pressure.
away. Yeah, tend to guess.
Well, I was just trying to wonder why we have it.
Yeah, when Ken, oh, come on, our field superintendent who served on the board, when he was on the board, Power, he explained that some of the ditches going into that thing were 25 feet deep. If I remember right, it was actually forcing the water up into the D-res. It's an expansion reservoir with a rubber top. It's like a big inner tube that's full of water. And when we were repairing it, George took it up and I could see the thing. So it expands and contracts with the water supply. It's a big ladder, that's what it is. Only it was rather expensive.
No, not really. It doesn't operate as a bladder. It
It's
doesn't
a-
pressurize.
It's a floating cover.
If this what has a cover over it?
So it's a big giant lake, basically, with a floating cover on it.
Oh, okay.
With a floating.
We can look that up. But it's a,
But there's no place up the plant to build something that big.
Yeah.
We couldn't build a reservoir
So,
like that.
don't take this wrong, okay, but so your point was, your question was,
Well, if we didn't need the reservoir, maybe we could use that.
oh,
Pump it down there.
Oh,
okay, I was trying to get why your question.
The other thing is, we got all this space on the other side of the McGill Red Dam that's no good, right? And we're gonna abandon this dam at some point in the future. But I guess not soon enough to put the whole, if you build another dam wall upstream of where the existing dam wall, we could have another reservoir right there between the exterior of the new dam wall and the interior of the existing dam wall.
as soon as any water in Little Deep Creek touches it, it becomes the waters of the US.
Yeah, but I'm talking about this as a holding pond.
But it still would require,
Yes, that
yes,
Place to
Yeah,
go.
I know. But you need a holding pond, I'm just saying,
You can't put it
the
in
whole
there.
dam, half of it's built. You just need to build another one on the other side.
but you need a holding pond to keep water from entering the Gallery Reservoir. That's,
We'd rename it, it wouldn't make it.
Yeah, that was a nice way out of that one, I know, we rename it, I know, non-water
Hunt
to the
reservoir
US.
sounds good.
Non-water to the US, is that what we're gonna call that one?
Well, I have one other comment, that's about the concrete tank with the open lid. That, they get anywhere from 50 to 100 inches of rainfall, is that figured into the thing for rainfall filling the tank? They really have some incidents of high water rainfall up there.
Yeah, it would be. I mean, we had looked at that initially here, and so we would continue to look at that. And that's, part of the oversizing of it, where, that graph there shows
So
1.2 million, but you'd oversize that tank.
Fortunately, it's only direct rainfall, not being run off.
The pole sheds that you wanted
yeah.
over here?
It's
The shed, what, oh.
What's that?
Oh, there's equipment on it.
12 inches built that.
About 12 inches. Yeah.
Yeah, make it a foot higher and we're good to go.
Yeah, that would handle any of that. Okay, is there any other questions from the public for Roger?
I just want to remind the board, at some point, if you keep moving forward, we got to comply with CEQA. So technically, we're not committing to any project before we analyze the projects under CEQA, including a no project alternative.
How long does CEQA take?
A no project.
Doesn't know what it takes, it's how much money.
Yeah.
It depends. I'm guessing the level of review is probably a negative declaration or something like this. And depending on if the district hired a consultant or if we tried to do it in-house, maybe 2 months to a period of 4 months or so.
Because we only got 24 months.
$20,000-$30,000.
Like, it could be kind of going parallel with that timeline.
As soon as we make a decision on which direction we're going to proceed, then we can do really start seeing the process.
Okay, but I'm just worried about the 20.
There's a lot of people that like your sequels right now, that industry is still in the jam, so.
Well,
You have to worry about that.
One of the ways we're going to discuss saving money is it should be a pretty low impact type project. So I may be able to handle it with some small assistance.
Saving us money.
And unfortunately saving money again.
Any other questions for Roger? Thank you so much, Roger, for coming tonight, girls.
Thank you.
Once late.
And Brian, thank
Appreciate
you
it.
for hanging around to the last. I appreciate it a little bit.
Not a problem.
We held off as long as we could. We waited till 9:15 and we
Yeah.
said, not here, we're going to start.
That's too efficient.
Yeah, we were actually at like 8:30.
We were done
I
at
hate to tell you this, Ken, we've actually.
Did you already go through the closed session?
Well, we've done everything.
Yeah, we went to the closed session.
We've had 3
Well, we haven't done
recesses,
everything.
we've gone slow.
We still have to do
We
8A.
took a 20-minute recess.
Oh, we tabled that, yeah.
We've got.
Oh, you're right.
Yeah.
We just put it in.
Not done this.
Can we just put it in just the next meeting, or do you need a decision on that tonight?
Well, actually, I don't need a decision based on what I heard. There's one person that was kind of hinging on the decision.
Oh, he's got a residence.
We can do it in June. Make it all
Okay.
business.
So we need a motion to move it?
It's already been,
He gets to do it.
He can-
yeah, we're gonna table, or move item 8A into old business and revisit it in June.
I thought this is one that we already made a decision on last month.
Well, now
We did clarification. on it.
we didn't do we only did the residential.
We'll explain the whole thing to you in June.
Yeah.
Yeah, trust me.
You can stay after.
We did, we did.
The reason we didn't do it is because two people have to abstain.
This meeting is adjourned.
So we need a full